Here's a video solution of problem number 13 from exam 2, Engineering 1301, fall 2018. Okay, so in this problem you're asked to find, or to write, the node voltage equations at each of the nodes shown in the circuit below. Okay, and so we're looking at this circuit. I see there's node A that's labeled, node B that's labeled, and node C. Alright, there was some confusion among some of you, I think, that this extra dot, that's really just the reference node, right? Because that wire could be collapsed down and just have a single dot if we wanted to redraw the circuit. Okay, so there are the nodes, and let's take these one at a time. Let's look at the VA node. Okay, so for the VA node, what you need to notice is that, if you try to slide the dot, here's a dot that moves from VA this way. Alright, here's a dot, we slide that up, we run into a resistor. Okay, we're kind of stuck unless we replace this with an equivalent circuit. Okay, so we know that the order doesn't really matter as far as the branch in the circle is concerned. So we can take this 12 volt source and rearrange the resistors to where I have a 6 in series with a 20, so to give me an equivalent 26 ohm resistance. Okay, so think of this branch as replacing the part in the circle. Alright, so here we would have VA, and here is the reference. So if I'm sliding dots here, I know this would be 0 through a rise of 12, we get 12 here, and so the current going this way would be VA minus 12 divided by 26. Okay, so that was the most problematic branch in this whole circuit, and that's how you handled that. So let's write them all down. So we have this current coming this way from the node, VA minus 12 over 26. Alright, then this current coming down this way is the opposite of the independent current source, so this would be minus 0.5. Alright, and then we have current coming this way. We see we have a series combination of 40 and 15 that we can write as 55. Alright, so plus VA minus VC divided by 55. And those are the three currents coming out of node VA. We had some problems with people forgot to make this an equation. Alright, so you have to have an equal sign for an equation. So the sum of the currents coming out of that node VA is equal to 0. Alright, so the keys here are finding the equivalent resistance and voltage combination for each branch. So here it was the 12 in series with 26. The equivalent resistance here on this branch coming back this way is 40 in series with 15. So that's how we get this 55 on the bottom. Okay, so that's the VA node. Let's do the same thing for VB. Alright, so let me erase all this. Okay, we're now looking at VB, and to get VB we need the currents coming out of the node. Alright, and so looking at the one going up, that's an independent current source, so it's in the direction of the current that we referenced coming out of node VB, so we'd write down 0.5 amps. Alright, then the current coming back to the left, alright, so that would be VB, and on the other side of that resistor is the reference node, so that's 0. So that'd be VB minus 0 over 18. And then finally we have the current coming to the right would be VB minus VC over 30. And again, sum occurrence equals 0. All right, and for the last node, VC. All right, so erasing all these. Okay, we have this current coming up, coming back to the left, and the current coming back down. All right, so looking at that, the current coming up, that would be VC, and the voltage across it is VA, and there's a series combination of resistance just like we did for node A. All right, so that would take care of the current coming up from node VC. All right, the current coming back to the left would be VC minus VB divided by 30. And finally the current coming down. So moving down we have this dot VC. So VC is right here. And then this is the reference node, 0. So this current coming down and back to the left would be VC minus 0 divided by 25. And again, sum occurrence equals 0. All right, so those are the node equations. It gives you 3 independent equations, 3 unknowns. You can solve for all 3 variables, VA, VB, and VC.